Next term, types of voids or holes. Types of voids or holes. So void space, that is empty space, which is present in the unit cells. So simple cubic unit cell, 52% is occupied by spheres and 48% is void space. And FCC, HCP, CCP, 74% is occupied by spheres, 26% is void space. BCC, 68% is occupied by spheres and 32% is void space. So voids, they are in two types, tetrahedral voids and octahedral voids. So first coming to tetrahedral voids. Tetrahedral voids or tetrahedral holes. So generally tetrahedral void is formed by 4 spheres. Okay. So 3 spheres belongs to a particular layer. Okay. For example, this is a layer. 3 spheres belongs to a layer. And 1 sphere above or below this layer. Above layer, either above layer or below layer. Okay. So this is tetrahedral void. Okay. So tetrahedral void is formed by 4 spheres. So when 3 spheres of a layer is in contact with a sphere which is present above or below the particular layer. So that is called as tetrahedral void. Okay. So tetrahedral void, a hole formed by 3 spheres of a layer in contact with 1 sphere of upper layer or lower layer. Okay. For example, unit cell having n number of atoms, there is a possibility for the formation of 2n number of tetrahedral voids. Why? Because tetrahedral void is formed in 2 ways, with upper layer atom and also lower layer atom. Okay. So number of atoms is equal to n. Number of tetrahedral holes is equal to 2n. Okay. Why? Because hole is formed with upper layer or lower layer. Next coming to octahedral hole or octahedral void. So octahedral void, that is generally formed with the 6 spheres. Octahedral void is surrounded by 6 spheres. So 3 spheres belongs to a particular layer, forms a hole with another 3 spheres which belongs to next layer. So another 3 spheres belongs to next layer. Okay. So this is octahedral hole. So this is A layer, this is B layer. Okay. Octahedral hole. So it is formed by 6 spheres. Okay. So octahedral hole, that is a hole formed by 3 spheres of a layer and another 3 spheres of next layer. So a hole formed by 3 spheres of a layer which are in contact with another set of 3 spheres of next layer. Another set of 3 spheres of next layer. So, number of atoms present in a unit cell is n. Number of octahedral holes or number of octahedral voids is also equal to n. Why? Because it is in contact with the next layer spheres. Whereas in tetrahedral void, it may be in contact with upper layer or lower layer. So there is a 2 ways. That's why number of tetrahedral voids are 2n. Whereas number of atoms are n. Coming to octahedral voids, number of atoms are n and number of octahedral voids are also n. Okay. Next, some objective bits related to this. So first bit. Total volume of atoms present in face-centered cubic unit cell of metal is. So, face-centered cubic unit cell contains 4 atoms in it. 1 is corner point and 3 are face-centered points. And volume of atom, volume of sphere, that is equal to 4 by 3 pi r cube. So 4 into 4 by 3 pi r cube. So volume is 16 by 3 pi r cube. So total volume is 16 by 3 pi r cube. Next, coordination number of a metal crystallizes in a HCP structure. So in hexagonal close packing. Okay, coordination number is 12. Okay, so coordination number for hexagonal if we take hexagonal close packing arrangement of atoms, that is in the form of AB pattern. Okay, first A layer, next at the depressions B layer. So if we take one sphere, it is surrounded by 6 spheres. Yesterday I told 6 spheres belongs to that particular layer and 3 spheres of the above layer and 3 spheres of the below layer. So totally an atom gets surrounded by 12 spheres. So coordination number is 12. Okay. And an octahedral void is surrounded by how many spheres? Just now I told. Octahedral void is surrounded by 6 spheres. So it gets surrounded by 6 spheres. The void between two oppositely directed planar triangles, okay, of spheres in adjacent layers is called octahedral void. Okay. So why? Because here triangle means it contains 3 spheres. So octahedral void is formed by 6 spheres. So 6 spheres in 2 sets, each set having 3 spheres. Okay. So two oppositely directed planar triangles, they forms octahedral void. Okay. Next, which of the following packing is more efficient, more stable? If a cube having more number of atoms, more space is occupied by the spheres, that is more efficient. Okay. So packing efficiency, that is more in HCP. Okay, 74% that is occupied by the spheres. Okay. Then packing efficiency in simple cube. Packing efficiency in simple cube is 52%. Remaining percentage is void space. The fraction of total volume occupied by atoms present in a simple cube, that is pi by 6. Okay. Pi by 6 into 100, that is equal to 52%. Which of the following has HCP crystal structure? So zinc having HCP crystal structure. Then a compound is formed by elements X and Y crystallized in a cubic structure in which X atoms are at corners and Y atoms are at face centers. Then formula of the compound. So X atoms are at corners. So corner points, 8 corner points are there. So 8 corner points, each corner point is shared by 8 other unit cells. That's why 1 by 8 part of it belongs to that particular unit cell. So X is 1. Okay. and Y atoms are at face center. So totally 6 face centered point, and each face centered point is shared by 2 other unit cells. So 6 into half. So that is 3. So formula is X, Y, 3. Okay.